Hello again. All right, we're going to do something very similar here to what we did in functions 3. In functions 3, we represented subsets of a finite set with a finite string of zeros and ones. Here we're going to do the same thing, except for our strings are now going to be infinite. A bit string is a finite string of zeros and ones. These are infinite bit strings. They go on forever. All right, but the process is exactly the same. Remember, we use 0 means not in the set. 1 means in the set. All right, and we have positions, right? So you can think of the first position in the infinite bit string as the position saying whether or not 0 is in the set. The second position, says whether or not 1 is in the set. The third position, 2 is in the set, right? Because we're starting at 0. So okay. Anyway, so we represent the empty set with. So here, empty set is represented with all zeros because none of the natural numbers are in there. Then moving on to this one, you see that we represent this with 1 and then infinitely many zeros after that. This just says that the first natural number, which is 0, is in the set. Okay, so now let's move on to this one. Okay, so let's figure out, okay, so remember this is the position for 0, this is the position for 1, this is the position for 2, right? So, and so on, right? So this says that, so this string, all zeros except for a 1 right there in the position that represents the number 2, this represents that set. Okay, all right, let's do the other ones. Okay, so how would we represent the set with only 5 in it? Okay, so 0's not in there, 1's not in there, 2's not in there, 3's not in there, 4's not in there, 5 is in there, and the rest of them are not in there. Okay, there's that one. Okay, now the set containing 3 and 4. Let's see, 0's not in there, 1's not in there, 2's not in there, 3 is in there, 4 is in there, nothing else is in there. 0, 1, 4. Okay, let's see, sorry. 0 is in there, 1 is in there, 2 is not in there, 3 is not in there, 4 is in there, 5 is not in there, 6 is not in there, and so on. Right, let's make sure. Let's see, the 1 here, that means that 0 is in there, okay. 0 is in there, 1 is in there, 0, 1, 2, 3, 4 is in there. Okay, so that works. We did that correctly. Okay, now the natural numbers take away 3. So this is all of the, so this set contains every natural number except 3. Right, so this would be, it has 0 in it, it has 1 in it, it has 2 in it, it doesn't have 3, it has 4, it has 5, it has 6, it has 7, it has 8, it has 9, so on and on and on like that. Okay, now the odds. All right, so 0 is even, right? So 0 is even, so we don't have 0 in there. We have 1 in there. We don't have 2 in there. We have 3 in there. We don't have 4 in there. We have 5 in there. And it just goes on like that, right? Even, odd, even, odd, even, odd, even, odd. Like so. And we can check. Let's see. This would say that 0 is not in there. That's true. This would say that 1 is in there. Okay. This would say that 2 is not in there. That would say that, let's see, that's 0, 1, 2, 3, 4, 5, 6, 7. Okay, so that does it, right? Start with even. So not in, not in, not in, in. Okay, now we got 5, 6, 7. So we don't have, so 0's not there, 1's not there, 2's not there, 3's not there, 4's not there, but everything else is. Multiples of 4. Okay, so that's 4, 8, 12, 16. And so on forever and ever and ever. So multiples of 4. Okay, 0 is a multiple of 4 as well. 0 is a multiple of 4, that's right. All right, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on like that. Okay, so that's how to fill in this table.